These notes are on systems of equations. Okay, I'm just going to introduce them, what they are. We are going to spend the next probably 3 to 4 weeks talking about this. Okay, but we need to know what they are. Okay, so system of equation is a collection of two or more, and that should say actually linear equations for what we're doing. So a collection of two or more linear equations, because we're going to focus on the linear side of it. And we are going to mainly be working with two equations. Okay, so an example, okay, x plus 3y equals 4 and 2x plus y equals negative 7. Okay, it looks very similar to what we've been doing the last few days, where we classify them. Okay, and so that's all we started with, just classifying those two. But now we're going to move on to solving them, okay, coming up with a solution. Okay, so a solution to a system is some ordered pair. If you don't know what ordered pair means, that just means a point on the graph that makes both equations true. So meaning I plug in that x and y, and both linear equations are true statements. Okay, so for example, okay, let's go back to the linear equations we had in the last slide. Negative 5, 3 is a solution to that system. And I can show you that by plugging in negative 5 for x and 3 for y. Okay, negative 5 plus 3 times 3 equals 4. And over here, 2 times negative 5 plus 3 equals negative 7. Okay, so I just plugged in that ordered pair into the x and y of both equations. And what you'll see is true statements. 4 is equal to 4, true statement, and negative 7 is equal to negative 7, true statement. Okay? Alright, so I'm going to show you some practice. The problem is my pen is not working. So you will, I'm just going to talk about them. Okay, so if you want to write this down, even though I'm not writing it down, you're going to have to listen. Okay, so if I take the point 1, 3 and plug it into both those equations, is it going to be true? So let's do this. And then these are fairly simple, so I don't know if I even need to write them in. But if I plug in x, or 1 for x, in the first equation, and 3 for y, 1 plus 3 equals 4. Is that true? Yes, 4 equals 4. 1 plus 3 does equal 4. And in the second equation, 2 times 1 plus 3 equals 5. Well, 2 plus 3 equals 5. That is a true statement. So A, it would be the correct answer. That is an ordered pair that is a solution. Well, let's look at B. Is that a solution? 0, 4. Well, you look at number 1, you say, okay, yeah, 0 plus 4 is 4. That's true. Oh, but over here, 2 times 0 plus 4 is actually not 5. That's 4. 4 does not equal 5. And same with C. I plug in 2 for x and 1 for y. 2 plus 1 equals 3, not 4. Okay, so right away you see that that's not right. While it does actually work in the other one, it doesn't work in the first one. Okay. And again, not having my pen is going to make this a little bit tougher, but I could go through. Okay. So if I looked at the first one, 5 times x. Well, if I want to plug in 1 for x, so 5 times 1, which is 5, plus 6 for y, is 11. That's true. Well, let's check the other one. 4 times 1 is 4, minus 6. 4 minus 6 is negative 2. Well, 2 times 6 is not negative 2, so that does not work. Try B. Plug in 2 for x. 5 times 2 is 10 plus 1 equals 11. Okay, that works. Over here, 4 times 2 is 8. 8 minus 6 is 2. Is 2 equal to 2 times 1? Yes, it is. And so B, therefore, is a solution. Okay, so what we're doing is just looking to see, are these solutions? And ultimately what we're going to get to is solving them. Okay, but right now we're just kind of, it's like checking our answer. Is this a solution? Okay, so that's our focus. Okay, and I'll see you tomorrow.